Hello everyone, good day. Welcome back to my channel. Today we are diving into something super important in financial mathematics, which is interest accumulation. Right. My name is SOA at Alate. I'm a student at KNUST reading Actuarial Science. Okay, so in my previous video we talked about the journey of an actuary. Now in the journey of an actuary I talk about the financial mathematics exams, which is the Exam FM. Right. Now for in that video we talk about the time value of money, right? And then the time value of money, for you to really understand Exam FM, you have to know the time value of money. And under the time value of money, one thing that you have to know is interest accumulation, which we are going to talk about today. Now this is the first part that we will be doing. In the next video we do the second part. Okay, so in this video we talk about what is interest, the two perspectives of interest, and then we talk about the amount function, the accumulation function. We do some exercise, right, which is exercise 1 and 2. So let's just dive into it. Okay, so one thing is, what is interest? Now interest is the cost of using money, right? So when you borrow money you pay interest, right? And then when you invest money you earn interest. Now someone may also say, is the reward for lending or the price for borrowing, right? Yeah, I agree with that, right? Because if you lend someone money, right, when the banks lend you money, you go and borrow the bank's money, right? They expect you to pay the money you borrowed in addition to a certain interest, right? So let's say you went and borrowed 200 Ghana cedis. They expect you to bring 200 and let's say 30 cedis, right? Which the 30 cedis is their reward for lending you the 200 cedis, right? And then the 30 cedis becomes a price to you, right? Because you are the one borrowing it, right? So the 30 cedis becomes the price to who? You. Okay, so I really agree with this, because it's the reward for lending or the price for borrowing. Okay, so the two perspectives, right? So sorry, there was a problem here. This is the borrower's perspective, right? So for you borrowing the money, you see the interest to be an expense, right, paid for using someone else's money, right? It becomes expense because you are borrowing someone money, and then you don't have to pay exactly the amount the person gave to you. You have to pay a certain amount in addition to what you are taking, right? So it becomes an expense to you, right? So from the borrower's perspective, that is an expense, right? And then from the lender's perspective, it's an income. He's earning something, right? So in the lender's perspective, interest is an income earned by allowing others to use your money, because his money is there and then you came to ask for it, right? So the moment you came for the money, you have to add something, and what you are adding becomes an income to him, right? So from the lender's perspective, he's enjoying, he's getting something, right? Sorry, he's getting something, so it becomes what? An income to him. Okay, now let's get straight to the amount function, right? So the amount function, determines the accumulated value, right? Or the amount function is the accumulated value at any point in time, right? So the amount function, in the actuarial notation for the amount function, is capital A of t, right? The capital A bracket open t. That's what we use to represent the amount function. So you have to pay attention to that. The capital A of t is used to represent the amount function, right? So is the accumulated value at any point in time. So pay attention to what? The accumulated value, right, at any point in time, right? Now the amount function can determine the accumulated value at any point in time, right? So the amount function is used to determine the accumulated value at any point in time. So you pay attention to that, right? Now we have the properties of the amount function. Now we say the amount function at time 0 is the money you invested, right? So let A of t represent the accumulated value at time t for an original investment of k. So we invested k, right? So let's say I'm holding k right now, right? So let's use some values. Let's say I'm holding 100 cedis today, right? And then I've not invested it. So that's at time 0. I've not invested it. What am I holding? 100 cedis, right? So we see the amount function at time 0 is k, the amount you are holding, the amount you've invested, the original investment, okay? And then we see the amount function is generally increasing, right? So it's an accumulated value, right? So it increases as time goes on. And then we say if interest accrues continuously, then A of t is continuous, right? Meaning someone might not understand the meaning of accrue. The accrue is to increase in value or amount as time passes, right? So something like the force of interest, which we will talk about in our next videos. So stay tuned and then subscribe to the channel and then continue watching the videos, okay? The amount of interest earned for period N. Now, to determine the amount of interest earned for period N, the amount of interest is also represented with a capital I subscript N, right? This is how it is. That's the amount of interest earned, right? So the amount of interest earned is, let's say you are holding 100 cedis today, and then at time 1, right, the next year you had to 120, right? What's the amount of interest earned, right? The amount of interest earned is the accumulated value, right, which is 120, right, minus the 100 cedis you were holding, so minus the previous year's investment, right? So that's how to determine the amount of interest. Now let's look at this example. Now an investment of 200 cedis is made into a fund, right, at time n, at time t equals 0, sorry. The fund develops the following balance over the next 4 years, right? Find the amount of interest earned during the second year. So this is the amount we invested, 200, right, at time 0, and then at time 1 it's accumulated, right, to 210 and 220, 231, 243. So looking at this, you can see that at time 0 is the same amount that we invested as the property of the amount function. At time 1 it increased, time 2, time 3. So the amount function is generally what? Increasing, right? So we are to find the amount of interest earned during what? The second year, right? So where is the second year? The second year is from time 1 to time 2, right? During the second year, right? So the second year is from time 1 to time 2, right? So you pay attention. If we were to find the amount of interest earned during the first year, that's from time 0 to time 1. But here is during the second year, so it's from time 1 to time 2. If it was during the third year, time 3 to time 2 to time 3, sorry. And then during the fourth year becomes time 3 to time 4, right? So in the previous slide, I said to find the amount of interest, that's A of n, the amount at that time minus the previous amount, right? So here to find the interest earned, that's the amount at time 2 minus the previous amount, which is at the amount at time 1, which is 220.50 minus 210, which is equal to 10.50 cedis, dollars, or any currency that you want it, okay? So you have to note that A of 2 is the accumulated value at time 2, and then I of 2 is the interest for year 2, as I said. So let's go straight to the accumulation function. Now for the accumulation function, it's a special case, right, of the amount function. But here the original investment is 1 unit. That is 1, right? So here it's not that the original investment is 200 or 300. Now here we are specific that the original investment is always 1. So keep that in mind. That means at A, the small a of 0, the original investment is what? 1, right? So keep that in mind. Sorry, I didn't tell you the accumulation function to we usually represent it with small a of t. That's the actuarial notation for the accumulation function, small a of t. So you pay attention to that, right? Okay, so the accumulation function a of t is the accumulated value at time t of an original investment of 1, right? So you record that a of t is the accumulated value at time t of an original investment k. That's the amount function. So to find the amount function at time t, you take the original investment k and then you multiply it by what? The accumulation function, right? So definitely that's how to find the amount function, the original investment times the accumulation function, because the amount function is the accumulated value, determines the accumulated value, right? The amount function determines the accumulated value at a specific point in time. Okay, so to find the amount function, the original investment times the accumulated value determines the original investment times the accumulation function determines the accumulated value at that time. Okay, so the second and third properties of the amount function still holds, right? That is generally increasing, and if the interest accrues continuously, then the function is also continuous. Okay, so as you see in the later lesson, the a of t and then small a of t can be frequently be used interchangeably. Okay, so one thing that I want you to pay attention is this. Keep this in mind, okay, because it really helps. Okay, and then the properties of the accumulation function and then amount function, pay attention to it. It really helps. Okay, so let's do some examples. Okay, so for the accumulation function, we are given the amount function a of t, and then we are to find the accumulation function small a of t, right? So to find the accumulation function small a of t, we say a naught, right? Or the accumulation function at time 0 is what? The amount we invested, right? The amount we invested, which is k, right? But here the amount we invested, to find the amount we invested, we have to substitute 0 to what? The accumulation function to find the amount we invested, and that's what we did here. And then we realize that the amount we invested, k, is equal to 2. Okay, so the next step is what? You use the relation. I told you you will need it. So the accumulation function is what? Is equal to the initial investment or the original investment times the accumulation function. But what are we looking for? We are looking for the accumulation function. So we just do a change of subject, okay, by dividing 2 by 2, so that the 2 cancels this and becomes 1. Okay, and then a of t becomes the amount function over 2, right? And then hooray, you substitute a of t, which we were given in the question. Okay, and then you find the accumulation function. So for you to know that your answer is correct, you have to remember one property of the accumulation function, and that is at the small a of 0 is always equal to 1. The initial investment of the accumulation function is always equal to 1, right? So when you substitute 0 into this, you check whether you get 1, and if you get 1, that means you are correct. Okay, so let's get into our exercises, right? So what I always advise you to do is to pause the video and then solve it yourself. and see whether you get it correct or wrong. And then when you get it wrong, you get back to it and then learn how to solve. When you get it right, you watch the video and then you see whether what you did was a new format of getting it correct, or you learn something from it. Okay, so let's continue. Pause the video and then solve it yourself, and then after that, this is the solution. Now, interest during year 6, right? The question was, you are given A of t to be what? This is the accumulation function, right? To be 1 plus 0.05t, and then II is what? The investment, right, at time 0 is what? 500, right? So 500 is invested at time 0, and the tax is to determine the amount of interest and during year what? 6. So during year 6, and what will be during year 6? From year 5 to what? Year 6, right? And then you have to find the general expression for the interest and during year 6. Okay. So to find the amount of interest and during year 6, you have to find the amount at year 6 and then year 5. And then remember that the accumulation function, right, at time t is equal to the initial investment times the amount function at time t is equal to the initial investment times the accumulation function at time t, which is what we just did here. And then this is going to help us find the amount at time 6 and then at time 5, and that's what we did here, right? And then subtracting from it, we had the interest to be what? 25. You solve it and then point it on your calculator to see whether it's correct, and then we go. Okay, so the B was the general case, right? Here we are not using values, we are using variable to determine the amount of interest that we will earn between an and then an minus 1, and then we had 25. Wow. So that means at any point in time, the interest earned each year is constant, right? And then we have a name that we call it. We will talk about it in our next video. Okay, so don't worry. Now, this is our second exercise. As usual, you pause the video and then you solve it yourself, and then after that you come back to the video and see whether you are right or wrong. Okay, so A of t, we are also given the accumulation function, and then we said 200 invested at time 0, which is the initial investment, will be worth 500 at time 10, right? So the accumulated value at time 10 is 500, right? And then what we invested is what? 200, right? So the question is saying that we have to find the accumulated value at time 15 if 800 is invested. Wow. So let's see how to solve this. And to solve this, looking at the question, to find the initial investment, A naught, that's 200. It was said in the question. And then remember one property that at A naught, which is at time 0, the accumulation function is always equal to 1, right? Okay, so at time 10, we were told that if I invest 200, right, times the accumulation function, right, at time 10, I'm going to get what? 500. That means the accumulation function at time 10, solving for it, gives me 2.5, right? Now, mind you, the accumulation function at time 0 is equal to 1. And looking at this accumulation function, if I substitute 0 into it, right, I get C, right? That means C is also what? Equal to 1. Okay, so you substitute 1 into the equation, and then to find B, we already know the accumulation function at time 10, so we say 2.5 is equal to this equation. By you have to substitute 10 into the accumulation function, and then 10 squared becomes 100. That's why we are having 100 here. Okay, so in case you don't know, that's why we are having 100 here, because we substituted 10, right? And then 10 squared becomes 100. and then you solve for b, which is definitely going to give you what? 0.015, right? This becomes our accumulation function, because now we know b and then we know c. Okay, so the task was to do what? The task was to find the accumulated value at time 15, right, of an 800 investment at time 0. So this is our initial investment. What do? We multiply it by what? The accumulation function at time 15, so that we get the accumulated value at what? Time 15. And that's what we did here. To find the accumulation function at time 15, you just substitute 15 into the accumulation function, which is this. Okay, and then this is what we did. We substitute 15 and then we had 4.375. Okay, and then to find the accumulated value at time 15, you just do substitution, and then the final answer becomes 3,500. So you have to punch it on your calculator to check if it's correct. Okay, now we talk about interest, which is the cost of borrowing or reward for lending. We talk about the accumulation function, which we said is the total money value at time t. We talk about the accumulation function, which is the growth of one value or one unit of money. And then we did some examples computing the accumulation function and then the amount function. Okay, so in our next video, which is the part 2 of the interest accumulation, we talk about the effective interest rate and then accumulation factor. Subscribe to the channel and then like, comment and share. If you don't understand anything, you put it at the comment section and I'll be very happy to attend to you. Okay, thank you for watching this video, and please subscribe to my channel. Okay, thank you. Bye.